One of the goals of Linera is to have low latency. Here we have a demo to show what that means and how that's a little bit different from other blockchains. So we have two browser windows and they're both running the same application. The application is just a simple token. So it's a fungible token and its ticker, we called it fun. So both browser windows, they're each connected to a different wallet. So on the left, we have a wallet with some tokens, and on the right, we have a wallet without any tokens. Both of the wallets are connected to the Linera Devnet. We're going to transfer some tokens from the left wallet to the right. So first I enter the target chain, and then the recipient's account. So what's happening is each of the wallets has a different microchain. So we're transferring tokens from one owner in one microchain to a different owner on a different microchain. So we're going to transfer, say, 5 tokens. And as you can see, it's being deducted and it has appeared here. So that's what we mean by low latency. It's the time between you send a payment and the receiver gets a notification or is able to see the result. So what's happening under the hood is quite interesting. So this is running on the DevNet. So we have a few validators running, and validators have multiple microchains inside them. In this case, the only microchains that matter are from the sender and the receiver. So we have one wallet, which is right now a command line user interface, a process running, but we are developing a web extension, so it's going to be more streamlined for users. And we also have the receiving user wallet, which is also a different process running, in this case, on the same machine, but it could be on any other device. Each wallet has a set of microchains it owns. It's basically the microchains it's capable of producing blocks or proposing blocks. So for the sending user wallet, it has the red microchain, and the receiving user wallet, it has the green microchain. It is also able to track other microchains for the interests of the user. Just for demo purposes, the sending user wallet is tracking a yellow microchain, but it's not going to use it in this example. And as we saw, the wallets are connected to a web UI. This is the front end that we see in the browser. When we transfer, a GraphQL mutation is sent to the wallet, the sending user wallet, which will then create a new block with a message, a cross-chain message, to transfer the tokens. So the cross-chain message goes to the green microchain. And what this does is then connect to the DevNet. To each validator, it will send the block proposal. Each validator will then get the block validated, and if it's okay, it will send back a signature. And once the client has all of the signatures or enough signatures to confirm the block, it will build a certificate and send that back to the validator. When the certificate is received, the validator can confirm the block. And that means the block is now final. Now, usually, this is the point where latency measurement ends on most blockchains. They're interested in very fast finality. And that's important, but Linera goes beyond, because both of the wallets can stay connected to the one or more validators, and that means it can receive notifications. In this case, one of the validators sees that there's a message to the green macrochain, which is one the receiving user wallet is interested in, so it sends a notification saying you have message. Then the wallet can communicate with the validator and retrieve the blocks it's interested in to check the message. So it can then keep in its set of track chains the blocks it's interested in from the sender. And if the wallet is configured to, it can automatically produce a block to receive the message. So that creates a new block proposal with the incoming message, and the same process applies. So first the block proposal is sent to the validator, it checks if it's okay, if it's valid, and then if it is, it accepts it and sends it a signature back to the client. The clients collect the signatures and builds a certificate and sends it back to the validator, which then finalizes the block. When the certificate is built, it can also notify the web UI that the block will be confirmed, because with the certificate, even if it's not yet sent to the validators, you can confirm it at any time. So then you have a notification that's sent to the browser that says the new tokens have arrived. So that is the full process which we're minimizing latency for.